Yeah, thank you so much for the invitation and the opportunity to talk to you about our experience with panelized prefabrication. Hopefully it's useful. I benefited from listening to other people talk about their experiences, so hopefully I can pay that forward a little bit. And I guess I didn't know about your October 29th horror stories, but we'll try and present this objectively. And there was definitely some lessons learned. Maybe not horror stories, but there's it's not all roses. So I'm going to just share my screen, and hopefully this comes through. Oops. And you see an image with a page with four
Yeah,
photos on
we've
it. Okay, perfect. So I'll
nailed
just
it.
take a minute. Thank you. I'll just take a minute and to say a little bit about us. We're based in Toronto. We're workshop architecture. I founded the practice with my partner about 15 years ago. We do a range of institutional type projects at the smaller scale. We're a small practice, so that involves a lot of renovation addition, sometimes to heritage buildings, some new build. We've had a deep interest in building science and high performance buildings for a long time now. And yeah, just looking at ways to integrate that aspect of our practice into projects that are not always they're not always signature projects for Passive House or new innovative technologies, but we still try and bring that in. And so that's kind of a theme that I'll talk about in this. And I purposely put this image in the top left. Some of you in Winnipeg hopefully recognize it. We were fortunate to work with the Forks and Sputnik with a previous competition entry, which was super fun to install about 12 years ago now, 10 or 12 years ago. Um, okay, so obviously I'll say I did this talk about 3 years ago, a version of this talk about 3 years ago for a Passive House conference. And so it was great to kind of revisit it and refresh it. And at that time, the second project that I'm going to talk about wasn't complete. It was complete to the tender stage, but it hadn't entered construction yet. So there's definitely a lot of whole second half of this presentation to kind of fill out that experience. But also in that time, in the 3 years that have passed, I mean, the whole discussion in popular culture and media about prefabrication, like we hear it constantly now, including like last week from the new prime minister and everything in between, and sort of bandied about as a catch-all and as a silver bullet to the sort of nationwide housing crisis. And so I think it's probably a bit esoteric for a lot of people, maybe not the people in this room, but it's probably an esoteric concept for a lot of people that read these press releases. And I guess from my perspective, or from what we're going to talk about today, is a very I guess specific strain or subset of prefabrication, and that's specifically panelized prefab, like was in the title. So as on the left-hand side. So panels that can be flat packed and shipped to site. And the reason I've kind of come to this version of prefabrication is, I guess, multi-layered. And we'll talk about it through the process through the presentation. But it's relatively accessible. We're talking about like conventional wood frame construction. So there's a lot of familiarity within the trades, within the industry with this type of construction. Obviously, it's used widely throughout Canada. So yeah, there's a lower bar of entry compared to volumetric. There's fewer elements to coordinate, fewer trades potentially involved. But equally, we still see massive potential for benefit, and that benefit being just tighter tolerances, better quality control, obviously like working in a factory environment versus on site. And this photo showing a bunch of snow in the background, just and less waste, all of those things. So for us, this is kind of a sweet spot based on our own research. Obviously, there's not a one size fits all for prefabrication, and there's place for volumetric prefab and all sorts of other things. But this is a kind of niche that we've seen a lot of potential in. And I think another way, or a way of summarizing that, is kind of if we imagine in like a retail world, the sort of holy grail of like affordable luxury, right? Like an idea sort of from William Morris or whatever of bespoke items that are handmade but are still somehow mass produced and available to a mass market at an affordable price. sort of a nice idea, maybe hard to actually deliver. So for me, this is sort of like customized standardization. Like there's a lot more design freedom, as speaking as a designer, compared to say volumetric modular. It's basically wood frame, which we know everything under the sun can be built with wood frame, especially when we're talking about engineered lumber being introduced into the equation as well. And the real only limitation is like 11 feet maximum dimension in one direction for shipping. So that still gives you like a massive amount of flexibility as a designer. So anyway, that's just sort of that's a bit of how we got to this point based on some research with other systems and whatnot. And the other thing is, when I gave this, as I mentioned, I gave this a version of this talk 3 years ago at a Passive House conference, and there was amazing projects, university projects, projects with, fancy facade designers, amazing full-scale mock-ups, all kinds of super cool stuff that I would absolutely love to work on, but it's not really in my wheelhouse in my practice. We don't have those opportunities. We're not working on state-of-the-art, $400 million university projects that want to, pioneer new technologies in offsite facade fabrication with casting cool forms in Germany and bringing them over. Like I love all that stuff. But this was sort of like, how do I get into this? How do I contribute to this discussion and this process with where I am in my practice and what my clients are looking for? And that was something that we really realized, we kind of had to drive, as is often the case. So how do we drive that agenda and open up those opportunities on projects that don't necessarily have the same mandate as some of these signature buildings? And so, like a lot of architects or a lot of probably people listening, I mean, we did that. We were our own guinea pig. So I was fortunate fortunate to have the opportunity to build my own house. So, and I use that as an opportunity both to as a passive house designer, passive house certified designer, to actually do a passive house project, because at that time no one was asking us for that. That's changed, fortunately. So we have many passive house projects on the go now, but that wasn't the case then. So it was an opportunity to kind of actually put that into practice. And we pioneered a few other things, and one of them was this panelized prefabrication. So I did a bit of research. I found a panelized prefab supplier locally here in Ontario, not too far from where the site was located, about an hour and a half drive. And I started a discussion with them, and right away it seemed it was a great fit. And I'll kind of walk through how that process worked. And there was, in addition to the sort of passive house agenda and the opportunity to kind of like pioneer for us this offsite fabrication, there was lots of other design agendas that we wanted to explore. And one of them was, I've always kind of been captivated by these 1960s California cottages by William Turnbull, if anyone's familiar, where all the interior framing, or much of the interior framing, is left exposed. So you see the studs, and I've always sort of thought that was really beautiful, just the simplicity of wood framing when there's some care and attention taken to it. And it seemed like a really great opportunity, given that a lot of high performance buildings, as you all know, we're really moving towards outboard insulation. And so the inboard stud framing really becomes a service cavity and the structural layer. So it's an opportunity to just omit basically the interior finish and leave all of that exposed, which is exactly what we did. So I'll just sort of talk about how that process worked and how that was successful. So basically I we designed the project. We created a Revit model. We gave the Revit model to the panelized supplier. They made their own model. They've since changed a little bit. Now they actually just work in Revit, but at the time they used a different software. So they basically made their own model from our Revit model, but of course they had something very accurate to work from. And this was just fantastic as a basically like a shop drawing submittal, to have this three-dimensional drawing. I could get a viewer download, and I could basically spin around it and cut it, and interface much like SketchUp. And basically this identified where every single framing member was in the entire building. So we could really control exactly as I was saying. Like we wanted to leave not throughout, but in many areas, the stud framing the structural layer, internal layer exposed, so we could control where where those studs were. We could control, harmonize like header lintel sizes for consistency, and kind of just really play with that in a way that I think would have just been unrealistic to expect in a site-built scenario. It would have meant basically me standing on site 8 hours a day and driving the framers absolutely nuts. So the other thing we did was we just asked for good one-side plywood to be used as a sheathing with the good side faced in, because that becomes the interior finish or the exposed finish, at least in areas where that was going to be exposed. There were some areas like wet areas, showers and things that obviously we applied a tile finish afterwards. So in those instances, they used like a chipboard sheathing. But in all the exposed areas, it's the good one-side plywood facing in. So that's a little bit about how this process worked, which was, fantastic, especially as a small Part 9 building, to have this level of control and detail. The other thing that I'll mention is we wanted to be able to pre-install the windows, but the timing just wasn't feasible. But I had such confidence in the precision from the shop drawing model or the fabrication model that I was comfortable ordering the windows, even though there was no actual rough opening measurement taken. So the windows were ordered based solely on that model. And it's a passive house project, so we were looking for a tight tolerance. So basically like 3/8 all the way around, or 3/8 times 2, I guess, 10 mil times 2, so 20 mil larger rough opening in X and Y dimension. So we went ahead and did that. I will admit I was a touch nervous before the windows came in, but they came and fit beautifully. So that's I guess a testament to that process, that accuracy, and that rigor in the shop drawing process. Okay, so then this is again kind of to just demystify the whole process. These are the panels getting delivered to site. They come to site packed in reverse order of how they're going to be installed. So they come off the site, come off the truck rather, and can be installed directly. I'll talk a little bit. This kind of falls a little bit into the horror story aspect of things, where one of the things that didn't go smoothly was that handoff between the offsite fabricator and the installer. They were not the same entity. They were two different trades. And so that's definitely something to be mindful of and to manage closely and carefully, which I'll talk about a little bit later. But here you see the panels coming off. Then they just get installed. It's a frost-protected slab on grade. Panels get installed from the back working to the front. Relatively simple. This is the whole thing put together. And I'll show in the second project a little bit more detail of just how membranes are left with an extra tongue to kind of lap over and seal everything together as it comes together. As I said, the windows were ordered separately. They arrived to site shortly after the panels, so they could be installed, in quick sequence. The rough openings worked, so there was a nice tight install. And this is it, completed or close to completed a couple of winters ago. And this is the interior finish. So as I was mentioning, stud framing exposed. I mean, the other thing, of course, is, among many things, of course, you could control the panel joints. So of course, these are individual panels. So we could control where one panel stops and one panel starts, where you'd have a double stud at that instance. We went to I can't remember if I said this, we went to a 24-inch on center spacing just to have a little bit less busy. And then the image on the right is kind of just showing like that inspiration from the William Turnbull cottages, where the stud space becomes an opportunity to kind of infill in between as a little shelf and things like that. And we worked through details like how to run services. Like we ran a few conduits below slab and whatnot so that we didn't have services running horizontally in between, in areas that were exposed. We worked out a detail. You can sort of see it on the right-hand side for a chase at the bottom. So where we're covering the bottom plate and just finishing that off. But yeah, this was the aesthetic that we were striving for, and I really feel like would have been much more difficult to achieve in a site built scenario. So in addition to all the other benefits in terms of waste reduction, performance, quality control, and whatnot, there was this kind of visual detail and experience that we were striving for here. I should say as well, I mean, in this instance, so the exterior walls, most of them, I mean, the exterior walls are load bearing. There's a few load bearing walls in the interior of the space as well, and those ended up being just made by the panel fabricator as well. I mean, there's no reason that they had to be, but it just was simpler so that in sequencing and in the install, didn't have to wait for one section of wall to get site framed and have the crane sitting there before a floor panel got inserted in. So they took that on as well, so that so the only bits that were site framed were a couple of nib walls and some bits around finishing, but really in the end, basically everything was offsite fabricated. Some lessons learned from this, or some things that we took away. Again, I guess the first bullet point, like design assist versus shop drawing. So as I mentioned, these really cool projects at the Passive House Conference with exciting big budget university projects. A lot of them in the presentations I heard were design assist, where there was these facade manufacturers and whatnot brought on board to work through details. I guess in a way I did that on this project, but moving forward, we're generally working in a public procurement like design bid build stip sum environment. So there's really not an opportunity for design assist relationship, much as we would like to do that. So, but I guess what I'm saying with this bullet point is the accuracy and rigor in the shop drawing process that the panelized fabricator came up with gave us confidence both with their working methods and the degree of information that we would get moving forward to these other projects that I'll talk about. That's sort of one thing that gave us confidence to sort of scale this up. Another thing that we kind of came across here and understood we would have to apply in subsequent projects is just like engineering by fabricator versus the design team. So in this instance, I mean, we submitted the building permit the conventional way. As far as the building department was concerned, I mean, they actually weren't even, I don't think it was explicit in our application that these were offsite fabricated panels. But regardless, I mean, all the structural sizing and whatever else was included on the design side. So, the fabricator was not taking design responsibility for the sizing of the studs or the joists in the areas of floor finish. It's a very simple Part 9 building, so that's not such a big deal, but it's something we had to be mindful of looking forward. Again, inspections, because this was all exposed, I mean, effectively the building department could do a framing inspection in this instance, but obviously that's a consideration if that's not the detail that you're looking at. And there's ways around that I'll talk about. I'm sure some of you are aware, but things that we did with that as we scaled up. Tolerance is a big one. So obviously the tolerances worked really well or the tight tolerances on the window openings worked really well. I've included this photo at the bottom. I mean, this is one of the things that was a bit of a hiccup. And it also just explains how the kind of install works. So basically there's a sill plate is site installed, and then the offsite fabricated panel has keys into that. So basically, once the sill plate is installed, they can drop the panel and work to that line. So obviously the sill plate has to be set properly, accurately. So our shallow frost protected foundation was purposely oversized in the X and Y direction by about, if I remember, 2 inches. So that just gave play for the plate to sit within that. And then that overage is just covered by the depth of the wall. So that was pretty simple to account for. What was a little bit unexpected was just the levelness of the slab. So we were fortunate. We had a great concrete pour that was very level, but our installer was sort of adamant about, I guess, a perfect sill plate, which I'm not sure that they were actually able to achieve. But what this detail is showing is basically setting that sill plate in a site installed bed of grout to get rid of, at least in theory, any deviation in the slab itself. This was kind of an issue for our details because it effectively lifted the panels up relative to the slab by up to half an inch. And we had a lot of instances you saw in the previous photo where we had benches or countertops that ran right into the sill. So raising the whole thing up wasn't ideal. I didn't know that this was the detail that they were going to do until it was already done. So the site was remote from my office. So although I was there regularly, I wasn't there every day. And sometimes people go on autopilot. So this kind of, we were able to work around it, but it meant that, for example, at door openings, there was a larger gap at the head of the door because the whole thing was lifted up, but the door is obviously still sitting at slab level. So yeah, we kind of thought about that tolerance in plan, but we didn't really think about accounting for that tolerance in the same way in section. So that was not a horror story, but as I say, I'm trying to be trying to present both sides of the good and the bad. Okay, so from there, we said that this was great. This was overall a success, notwithstanding these small hiccups to work through. And we'd love to be able to apply this to a larger project. So, and that's the one that I'm going to talk about now. So this is an existing building, obviously. It's a 16-unit seniors apartment building owned by Toronto Community Housing, owned and operated by Toronto Community Housing. It's a pilot project for them on a series of fronts. It's a deep energy retrofit. This is the brief. It's a deep energy retrofit, piloting like a geothermal heat pump and a whole bunch of other technologies in partnership with Toronto Atmospheric Fund. And so we saw the proposal call come out, and we said, okay, checks all the boxes, and it also the building seems like it's a good candidate for an offsite overclad, like offsite prefabricated overclad panels. And these are just some of the considerations that we had to sort of look through and convince ourselves and convince ultimately the client that this was a fruitful avenue to pursue for their projects. So I'll talk about these in a little bit more detail. So first things first, I mean, it's a relatively small building. It's definitely like a residential domestic scale. The units are very small. 8 studios and 8 single one bedrooms. The geometry is very simple. So in the photo in the top, you see some overhangs and some balconies. So the balconies were kind of rotted out anyways, and the 2x10s were kind of just framed directly into the exterior masonry. That was going to be cut away anyway. So once you cut away the balconies, and ultimately we cut away the roof overhang and ultimately reinstated it, but you end up with almost just a rectangle. So simple geometry, not a lot of ins and outs, not a lot of cantilevers. Not that those things can't be accommodated with offsite fabricated panels, but it's a good starting place, right? Like very regular openings, simple geometry, great. The other thing, yeah, as the second bullet point says, based on the scale of the building per OBC, it permits combustible construction. So again, there's different ways you could fabricate overclad panels, but what we're talking about is a kind of wood frame scenario. So that's, again, eligible. Client, as I said, already had these very aggressive energy reduction targets. They wanted to pursue passive house or EnerFit as a renovation, which is great. The TCH has as a mandate, I mean, these buildings are occupied when this work happens, because there's simply not place to relocate people within the overall, portfolio. Plus, it's disruptive either way. It's disruptive to have the work happening, but it's equally disruptive to move someone out and move someone back in a year later, or 8 months later, or whatever the case may be. So they have a very strong mandate of minimizing tenant disruption. So again, the ideal with the prefabricated panels is it would reduce time on site. It would reduce that disruption to to the residents. And the other thing that was just fortuitous is, as I said, repeatable solution, the bottom point. So this specific building, I guess it was a repeat design back in the 60s. So this project is only one, but TCH actually owns 14 other identical buildings. So we thought, great, let's try it here, and hopefully it's successful and it can be rolled out at some other buildings that you own. Challenges, like I said, I mean, this is it's a very stringent public procurement. So there's limited opportunity. I mean, as this slide is saying, I mean, everything's got to be, we're not sole sourcing. We can't sole source. We can't bring a partner on board in terms of a prefabricated panel manufacturer. We can certainly liaise with them, but there's no guarantee that they're going to get the project. So understandably, there's limit how much they're going to invest up front, which is totally understandable. So, but fortunately, we had this relationship with the panel supplier that we had worked with previously. We reached out to others as well. And we sort of just talked to them about the project. Is this something that they would bid? Do they have any initial inputs? And then what we did was just developed a spec section that I wasn't previously familiar with, but does exist under the master spec table, which is this prefabricated wall assemblies. And we just collapsed all of these items that you see on the right-hand side into this spec section. And that's how it ultimately went out to market, went out to tender, with the expectation that all of these components would form part of the prefab wall panel. So unlike the example that I showed previously, we wanted to kind of increase what was done off-site. So we wanted the windows to be installed, and ideally we wanted also the cladding to be installed before it was brought to site. That was the goal we set for ourselves, and that was how we structured the tender documents. So yeah, we basically just created a set of details that were, I think, generic enough that they were flexible for different, depending on techniques or specific preferences of different panel manufacturers on the marketplace. It's relatively simple. It's a relatively simple approach with continuous steel ledger at the base to support the panel. We did testing of the existing building to verify the capacity of the masonry to hold that anchor with pull-out tests and whatever else and satisfy the building department. But ultimately, that detail was still the responsibility of the panel supplier. Some lessons learned, as I mentioned in the previous, about just incorporating tolerances. So we purposely made it's difficult to see in this image, but we made the new window openings slightly smaller than the existing. And so they obviously were tight in the new rough openings in the panel, but they're smaller than the existing window. So just any interferences in terms of existing trims or whatever else wouldn't get in the way. And then we just finished that off with an interior detail. So yeah, I guess the other piece of the puzzle is just making sure that there's actual market interest and market availability to bid on this thing. So as I say, we spoke to a couple of suppliers, the one that we had worked with, plus some others, just to gauge interest and make sure that they would actually submit a bid for the project before it went out, and they confirmed they were interested. I will say that I think the markets maybe changed a little bit or matured a little bit, but at that time, those suppliers, they're very much working in the sort of single family home market, probably working directly certainly with a contractor, with a homeowner, possibly in a lot of cases without a consultant involved, certainly not involved in a detailed way, the way we are typically involved in institutional projects. And so we just wanted to make sure that they understood that, certain responsibilities that they maybe don't have on typical projects, they are going to have if they're bidding this. So just making sure they understood, shop drawing requirements, that there would be engineering in this instance pushed back on them. So, I mean, the easiest way I think to describe it is it's treated sort of like a curtain wall, like, the panel supplier is responsible for, engineering that their own product stands up, that their own product is capable of supporting the cladding, that their own product, any connection details back to the backup wall, which in this case is masonry, is their responsibility. We also had obviously stringent thermal performance requirements. And given the spec was open and, there's different installations or different methods, obviously different extent of thermal bridging, depending on exactly how they frame the panels. So we needed verification, like proper thermal model of their panel itself to verify that we're achieving specified requirements. In this instance, because it was all kind of rolled into, a design bid build contract, the installation responsibility, I mean, we ultimately don't sort of dictate that, it's all the contractor, but just to make them mindful and have that discussion with the GC in terms of who's doing what. And then the last one is it's pretty banal, but it's a huge issue, and I'm sure you've probably come across it or aware of it, is like payment terms and financing. And this is for any prefab project, because obviously the typical CCDC2 language is that the contractor only gets paid for work completed and materials on site. In this case, they're doing a huge amount of upfront work off-site. How do you reconcile that? And that was a big issue on this project. And as much as TCH was a fantastic client in terms of piloting these things and pushing the envelope and being setting really, really ambitious performance targets, the whole legal aspect and contract aspect and any sort of allowance for advance payment doesn't really fit into their model at the moment, or didn't with this project. And so that became a challenge and something to work through with the contractor. Again, just in terms of demystifying, so this is the panel fabricator's shop. And I went and looked at the panels before they were sent to site. They're all cataloged, they're all numbered. Obviously, they're stacked on the truck based on the installation sequence. The image that you see in the bottom is just, again, examples of, surplus membrane kind of with the back adhesive not pulled back to sort of, once the fastener is driven all the way in, you just peel that back and cover it over. So that's sort of done throughout. There's some other examples of that, and really nicely worked through how panel to panel to rough opening, how all these junctions work to kind of really simplify it on site. And so then this is the site itself. So if you recall from the first image of the existing building, so the balconies have been cut off, the roof overhang has been cut off. It's all dark gray because there's a liquid applied air barrier, applied to the entirety of the existing building, existing masonry. The existing building actually also had metal cladding on the gable ends, like the image on the left. Which was added at some point. It wasn't original, so that was peeled off. And then what you're seeing is basically, you can't really make it out in this photo, but there's the steel angle ledger at the base. There's a sort of I think it's a 2x10 or 2x8 ledger at the floor line, and then another at the top. And so that's ultimately how the panel supplier, because we weren't sure if they were going to panelize in terms of tall, skinny panels, like 2-story panels, say 8 feet wide by 24 feet tall, or whatever it ended up being, or split it the other way as sort of a layer cake. That's ultimately what they ended up doing. So there's an intermediate ledger at floor level that allows for anchorage at the head of the one panel and the base of the second panel, and they kind of nest into one another quite neatly. And so what you're seeing is then mineral wool insulation, 1.5 inches of mineral wool insulation being added the same depth as that typical ledger, so that 1.5 inches. So rather, we wouldn't want an airspace behind the panel, so that insulation is site added, and that obviously factors into the overall wall assembly performance. And then on the other side, you're seeing a panel on site, sort of propped up, ready to be installed. And these are the panels themselves being installed. Yeah, just lifted into place. You see the ledger, the steel ledger on the top right. And then what I'm showing on the bottom right is just, so the part of this project was adding decentralized ventilation to each unit. So every unit has an in-suite ERV. And so there's obviously a a penetration or two penetrations, supply and exhaust for each ERV. So it's just a knockout, just a gap in the framing. That's where again you see the extra membrane that's left when the panel's factory fabricated. So when they come to site, they just fill the area around the stub on the duct with mineral wool and bring the membrane down, seal it to the field, and cut out and seal around the duct. The duct's also sealed back at the masonry penetration because the mento layer that you see here is just the weather barrier. It's not the air tightness layer. The air tightness layer is back behind. So, but still a second seal. And then this is what it's starting to look like now. I mean, yeah, as I say, we started with an ambition about having the cladding and windows installed off-site and arriving with the panels. That did not happen, as you saw from the previous photos, unfortunately. I think this was if I'm frank, I mean, in a design build scenario, we were really trying to kind of maverick this and kind of just, how do we, as I said at the start, how do we bring some of this thinking, this technology to a project that's, not otherwise specifically, driving the prefab? Can it be kind of just simplified into a way that, it just is part of the project, just like if it was site built, no big deal. There's still, people interested. There's still suppliers interested in whatever else. So I think that was the case, and I think there was market interest from the prefab side. I would say on the GC side, they were a little less enthusiastic about it. We didn't have the opportunity to like pre-qualified GCs that were explicitly, specifically interested in this. And I'm sure a big part of that was the funding mechanism, because as I said, like they were not able to get, under the terms of the contract, they weren't able to get paid for, windows and cladding up front for material that was in the shop. So that really, I think, reduced their appetite for pursuing that, unfortunately. So we didn't get to test that, but we certainly got to test some of these other things at a larger scale. And that's it. So I'm under time, which I hope is a good thing. And there's time for some discussion and questions. And hopefully I didn't gloss over any of that stuff too quickly, but I'm happy to go back if there's go back to any of those images, or obviously if there's specific questions, hopefully I can add to
Yeah,
them.
that's great. Thank you so much. This was such an interesting presentation. Really appreciated that you were open with the things that went well and the things that didn't go well. As we all know, there's so much to learn from that side of things. So folks can either put their hands up to ask questions or drop your question in the chat and I can read it out. So your first question is coming from Bob, and he's wondering, what foundation is the home sitting on?
So the first project, yeah, so it's just it's a frost protected shallow foundation. So it's just like, I guess, a 6-inch slab with a slab thickening at the perimeter and thickening under a few load bearing points, and just on a I forget the depth of insulation, but it's an EPS insulation that was basically like a big jigsaw puzzle. Yeah, I didn't really talk about that, but it's basically, it was like pre-cut, yeah, to put together as a big jigsaw puzzle, and included a little curb upstand at the perimeter and a skirt around the edge. So yeah, so we didn't have like a conventional strip footing. We had a minimal excavation. There's no crawl space. There's no basement. So that's, I mean, I'm sure some people are familiar with those. There's we had we just based on the geotechnical investigation and the soil type, we had the geotechnical engineer input on what what level of insulation you would need to prevent frost heave, and what how suitable it was for a shallow foundation. And in that site, it's on Georgian Bay. It's basically a big sandbar, so everything is sand. So as opposed, like, yeah, water just runs through it. Excuse me. Um, so there's not as much concern about frost buildup like with a clay or whatnot.
Mm. Okay, so are the connection details available to share?
For which project, I guess. I think I have to think about that. I mean, it's I think back to my comment about customized standardization or like affordable luxury. I mean, it's really like pretty conventional carpentry connections, right? That's what I love about it. It's really, I mean, at its core, it's stick framing. So, there's a million different ways you can connect, especially now, with all the sort of big fancy heavy duty fasteners like from the CLT world and whatever else, like the really, the $30 screws that you can drill through the 2x10 the long way and all this kind of stuff. So, I mean, it's effective. Like the cabin is really just platform framed. Really no different than if you had site framed it. The It's a little trickier on the overclad project, not surprisingly. As I said, it's sort of the whole thing sits on that steel ledger at the base, and then at the intermediate joint, I mean, it's sort of like a big tongue and groove. Like the one panel goes up behind first and fastens in, and then the second panel nests into it and fastens through as well, if that can describe it. And that was a detail that was ultimately, that the panel fabricator came up with that detail, and they were responsible for engineering it. So we needed that, engineer's seal on that connection, just confirming its ability to hold itself up and to fasten back into the substrate, if that makes sense.
Yeah, absolutely. I think so. If not, people ask
Mm.
questions for more clarification. Okay, so Evan's wondering about what the liquid AVB is that you used.
Right. So yeah, as I said, I mean, in these public projects, like it's all has to be open spec. So we just defined the performance characteristics that we needed. And I mean, do you guys know, I'm sure you do, 475, who carry like all the nice European membranes. So for compatibility, I believe it was one of their liquid applied membranes, but I would be wrong about that. But we just needed I mean, where the tapes overlap on the liquid applied, we just needed obviously confirmation of compatibility of adhesives and whatever else. So sorry, that's not a great answer, but I think it's out of the like 475 like SIGA suite of products. I can follow up with Laura on that and confirm.
Yeah.
But the spec was definitely open. Like it has to be on these projects. So we would have had multiples named, whether it was just like a Baker or John's Mansfield or whatever, one of these or Flynn, something like that. As I said, the performance would have been defined and the compatibility requirement would have been defined. So
Okay, thank you. We've got some curiosity about the mechanical with the open walls.
okay. Um, in what respect?
So I guess it's about the cabin and just
Mhm.
curious how that all like fit together given the fact that the walls were open.
Right. Yeah. So I mean, the walls, the stud framing is exposed, but obviously there's like 14 inches of insulation outboard. I'm not sure if that's the question. So I mean, the cabin is, yeah, highly insulated, like you would expect from a passive house project, and just has an air source heat pump with minimal and an ERB and minimal ductwork distribution for it. It's been a couple of years. I can say it's very comfortable. Um, and yeah, the triple glazed windows, you can sit in the deep window ledges even in the middle of winter and be comfortable. So, so hopefully that's clear, or that's response to the question.
Yeah, you got a thanks in the chat for that one. All right, so Patrick is wondering what are the other CCDC2 items that were challenging with the panelized approach?
Yeah, so I mean, I guess it's maybe difficult to parse exactly what's specifically, well, the payment thing, 100%. That's a CCDC2 issue. That's a challenge. CCDC2 slash like rigid public sector client. There's obviously means in CCDC2 to certify payment for material that's not on site. I'm sure people have come across that, like we've come across that, but it tends to get messy. Like it's supposed to, you're supposed to have material in a bonded warehouse or whatever else. I mean, I think in this case, like with as I say, like with a large institutional client that has a relatively rigid process, there wasn't a lot of latitude to do that. But other challenges, I'd say maybe were partially in the CCDC2 camp and partially just in lack of familiarity with what we were trying to do in the market from the GC side. Or I guess another way to say it is because it was basically it wasn't an open call. It was Toronto Community Housing has like a roster of contractors, but they've obviously been pre-qualified just generally across their whole range of potential projects. They're not pre-qualified specific to this project. So they kind of this thing just landed in their lap as, the architect or the client is pursuing prefab, right? So there was no, although we obviously talked about it and it was clear in the documents and we talked about it at the bid walkthrough and all the rest of it, it wasn't something that, that was sort of vetted or discussed in advance or could be used as a, familiarity with the process or previous project examples used as a means of, I guess, like scoring the contractor's submission and things like that. So yeah, I mean, I think the biggest thing 100% is the payment terms. The second thing was just that, we were kind of taking a bit of a flyer and just putting something out to market. And we'd done a lot of research, as I said, on the panel supplier side and to gauge their interest and their willingness to provide bids to GCs. What we hadn't done as much work with, and I'm not sure we could have or would have changed anything, was like working with GCs and saying like, hey, this is, get them to come to a session like this or talk to them about what we're trying to do beforehand. So, like you don't really choose your dance partner in that environment. So I'm not throwing them under the bus. Like they did what they had to do, and I think the end result is good, but it would have probably been smoother, yeah, if everyone went in sort of eyes wide open that this is how we're delivering the project. But I guess that's sort of where we started from is like how do we bring this into just the mainstream? Like what happens if we just drop this into the market and see what happens? So,
Yeah, absolutely. On the subject of CCDCs, have you ever used CCDC 30? And if you could just say what CCDC is, just in case somebody missed that, that'd be useful too.
yeah. So CCDC is what? Canadian Construction Document Corporation. Anyways, it's the standardized construction suite of standardized construction contracts that most larger institutional clients tend to use. Obviously, they modify them with their own supplementary conditions and whatever else. So yeah, sorry if I kind of glossed over that. So I mean, the CCDC2 is where there's, you're as a designer working kind of on your own, you develop a design to 100% and then you put it out to market and get bidders. So it's not like a 5 or 5B. Yeah, I thought 30 was integrated project, but 5, this would also what could work well with a 5 or 5B, like a construction management, where that's sort of the gap I was just referring to before, where we didn't have an opportunity. We didn't know who the GC was going to be. We didn't have an opportunity to kind of talk to them about what this approach was, gauge their familiarity, comfort level, and whatever else with it, and work through some of the connection details in advance and whatever else that would obviously be useful. At the same time, as I said, I think there was value in kind of just trying this out and sort of seeing how the market would respond. So to the question, I think that started this is, have we used CCDC 30, which is the integrated project delivery? And I have not myself. It's come up a lot. I'm sure I don't know in your market, like in the market that we're working in Toronto, there's increasingly the construction inflation and lack of certainty around pricing is opening doors to different project delivery methods that were previously closed from institutional clients. Like previously, we didn't have any interest when we proposed construction management on projects. It just didn't, there was no interest. Now there's more interest. That we've seen RFPs out for IPD. We went in with a team, bid on some, haven't had an opportunity to work on it. Yeah, I mean, obviously that would be a great, this would, that would iron out some of the things that we've talked about, or potentially that would be a great way, as with, has lots of potential, not just with prefabrication. So, and actually, just to close the loop, I mean, the same client, same owner, Toronto Community Housing has recently put out a proposal for an IPD delivery. So, yeah, hopefully coming, and we'd love to work on one, but not yet.
Yeah, fair, fair, fair. All right, we have a question about the fact that Retrofit Canada is putting together case studies and best practices for retrofits. So have you been in
Okay.
touch with them to create a case study on this project?
No, I haven't, but I'll write that down.
Sounds like we might have a connection here. All right. So the chat has slowed down when it comes to questions. So I'm just going to give it a beat to see if anybody has that courage that they were just go for it. Write your question down, and get it out there. I know personally, sometimes I'm like, oh, does this question make sense? So I get you if you're a little slow on it. Just going to give it one more beat, and then we'll wrap it up.
Sure.
All
I guess I
right.
mean, just for
All
my,
right. Well,
I was
please.
gonna say for my benefit, I mean, I think we spoke, obviously we spoke beforehand, but I mean, in terms of the group, maybe I should have said this at the start. My understanding is it's the audience is made up with a group, a range of like consultants and, engineers, maybe architects, but also people on the construction side. I don't really see the full list, so I'm not sure how many people are here, but I just see your names anyways. But anyway, I mean, hopefully this kind of bridged the gap across those different sort of facets of our industry, and there's something for each discipline or each group to kind of take away from. But yeah, as I said, it was anyway. I mean, I feel kind of I feel a little bit. I don't feel like I'm expert in this, and I'm really just kind of showing this as how we, as I said at the start, like we wanted to be involved in this in this aspect of building and trying to move the needle on it, and in the absence of specific client direction in it, just kind of tried to push that envelope a little bit ourselves. So and hope to keep doing it.
Absolutely. It's very interesting, great, well laid out presentation. So thank you so much, David.
Yeah.
Somebody wants to know, do you see any potential for tighter specifications for prefabricated wall and systems in the future? Ooh, tongue twister.
Yeah, and actually, I didn't put it in the notes, but I had it as a written to myself, and then I forgot to say it. So what we included in our specification. So I've seen some really inspiring examples of like prefabricated overclad panels. Like certainly we're all just sort of standing on the shoulders of the people that have done the stuff before us. So I mean, I'm probably some of you guys are aware of some interesting projects that were done in Edmonton. I wonder if was it like Sundance Co-op or something like that, and where they literally just built they built the panels in the garage right next door to it, right? And it was really like it was even kind of a little more maverick than what I was showing here. And I think that's again a testament to the sort of customized standardization. Like that's literally something that you can do. I think in what we came to is we wanted to open the market up to enough qualified prefabricated panel suppliers. I mean, that's sort of just the nature of dealing with a relatively conservative institutional client. And so what we included in our specification was that the panel manufacturer had to have CSA A277 certification. So that kind of, even though I think, any competent contractor is more than capable of doing this in a relatively small space, 100%. And I hope that it kind of filters down to that level. That was, I think, a bridge too far for this project. So there was the A277 stipulation, which kind of narrowed the field and obviously like institutes a level of quality control. We didn't specifically need that. I mean, like that, I think that designation's largely not, I mean, it doesn't have to be, but it's really there for like Part 9 buildings and instances where, it's there maybe isn't a consultant on board and a building department needs some assurance, obviously, of quality control, given the, building inspector is not going to necessarily go to some far-flung factory to review this stuff. So, but at the same time, we put that in there nonetheless on this project, just as a sort of, floor, a baseline for the panel suppliers. So yeah. And I mean, hopefully more people get that qualification, but
Yeah, hopefully more indeed. All right. Well, thank you so much, David. This was a great
thank you.
presentation. Really appreciate you sharing. There's so much to learn from other jurisdictions, and Manitoba's keen to figure out a bunch of this stuff.
Great.
Yeah, so just a reminder to everybody that we're still collecting the horror stories. Thanks for highlighting some of the things, because there's so many things to learn, both from how it goes well and how it doesn't. If you don't catch this form here right now, folks, you can get it off the SBM website. But just a huge thanks to you, David, and to everybody who came and listened and
Yeah.
learned.
Thanks so much. Yeah, it was great. Thanks for reaching out to me. And yeah, it was great to try and synthesize my thoughts on this and share
Well,
share with
good
you
job
guys.
synthesizing. Thank you. All right,
That's great.
everybody, have a great rest of your day, and we'll
Thank
see you here
you.
next time.